Okay, so elastic collisions are ones where the total kinetic energy before equals the total kinetic energy after the collision. Now, that means no kinetic energy was lost. It does change, like the kinetic energy of the objects before the collision will be different than the kinetic energy after, but the sum of the kinetic energy of the two objects before will be the sum of the kinetic energy of the two objects after. We told you that you can easily solve problems where they don't give you the mass, but they give you the three of the velocities, like u1, u2, v1, and v2. They give you three of those. You can solve for the other one simply by using this equation, as we did before on the simpler problems on the last video. But that's only true for elastic collisions. So let's look at this problem. Now it's a little different because they gave me the masses. So let's see. I'm going to start out with the collision equation where they don't stick. Okay, so U is the original velocity, V is the final velocity. Okay, so let's plug in the numbers, what we got so far. So we got M1, let's call that M13. It's moving 8 meters per second to the right. Okay, so positive 8 is the original velocity of the first ball. Then the second ball is 5 kilograms. He's moving to the left with a speed of 2. So you're going to have to put -2 there because he's moving to the left. And you got to put velocity in rather than speed because momentum's a vector. Okay, so we have M1 and then V1. I don't know what that is. Oh, wait. Okay, so the 5 kilogram, I don't know what that speed is either. So I don't know either of those speeds. So I'm kind of stuck here. Let's do what we can. So 3 times 8 is 24. Minus 10 is equal to 3v1 plus 5v2. This is about, okay, so 24 minus 10 is 14 equals 3v1 plus 5v2. That's about as far as I can go with that. So let's keep that. Okay, that's the conservation momentum equation. Now, I'm going to use that trick that we used before up there, this equation. So u1 plus v1 equals u2 plus v2. Only true for elastic collisions. Okay, so u1 I have is 8, v1 I don't know, equals u2 I have is -2, and v2 I don't know either. So let's get the numbers on one side and the v's on the other side. So add 2 to both sides. So we got 10. Let's subtract v1 from both sides. So 10 is equal to 0 plus v2 minus v1. Okay, so now I got, let's rearrange that. So I have v2 equals 10 plus v1, right? Now I'm rearranging that because now look what I have. I have v2 here, and I have v2 here, and it has v1, so I can solve for v1 by substituting these two equations into each other. So let's do that. So 14, I'm going to just rewrite this equation up here by 3v1 plus 5 times v2. So instead of v2, I'm going to just put 10 plus v1. So 14 equals 3v1 plus 50 plus 5v1. So now I can put the v1s together. Sorry, v1s. So I have 8v1, and then subtract 50 from both sides. So I got 14 minus 50. So you see what I did, right? Negative 50 from both sides. And then add these two guys. So I get 14 minus 50 equals 8v1. Okay, 14 minus 50. So we get negative 36 equals 8v1. So v1 equals negative 36 divided by 8. That equals 4.5. Negative 4.5 meters per second. So now I can go to this equation right here, and solve for v2, having v1. So v2 equals 10 plus v1. So v2 equals 10 minus v1 plus the negative 4.5, because that's what I got up there. So I'm going to get v2 equals positive 5.5 meters per second. So there are my two answers. Now, the next problem, I kind of reworded it kind of badly. So let me clarify something here. So 2 kilogram ball is moving 5 meters per second to the right. Okay, so let's draw that. Okay, this is M1. So this is ball 1, 2 kilograms, moving 5 meters per second to the right. So U1 equals 5 meters per second. M1 is equal to 2 kilograms. Okay, it's going to collide elastically and head-on with a ball of unknown mass. So I don't know what the mass of this is. So M2 is a question mark. And he's moving 3 meters per second to the right. So U2 equals 3 meters per second to the right. Okay, after they collide elastically, the 2 kilogram bounces at a speed of 4 meters per second. Now, I should say it doesn't bounce backwards, because I tried it with a -4 and I got a negative mass. So just to tell you ahead of time, I should reword this. So 2 kilogram ball, I should have said, continues moving at 4 meters per second. So that's V1. He lost some of his speed. And ball 2, I don't know what ball 2 is doing, but obviously he has to be moving to the right after he bounces. So I don't know his mass, and I don't know V2. So what we're going to do is start with the simple equation, probably. No, let's start with the conservation momentum equation, this. Okay, so let's plug in our numbers. 2 times 5 plus M2 times 3 is equal to M1. M1 is 2 times V1, 4, plus M2, which I don't know, V2, I don't know. So let's clean this up. 10 plus 3 M2 equals 8 plus M2 V2. Okay, so let's get the 10 and 8 on one side. And let's cross out let's get the M2 on the other side. So let's rewrite this. 10 minus 8 is 2 equals M2 V2 minus 3 M2, which we can write as M2 V2 minus 3. Okay, so that's my one equation. I can't do anything. I have 2 unknowns, so I look for another equation. And so what I'm going to use, is the U1 plus V1 equals U2 plus V2. So U1 is equal to 5. V1 is equal to 4. U2 is equal to 3. And V2, I don't know, but I have just found it. I can find it now. So 9 minus 3 equals V2. So V2 equals 6 meters per second. Okay, so let's just look at that. This ball bounced back a lot that way because I got a positive number. So next I'm going to use that V2 and combine it with that equation that I just solved from the conservation of momentum. So let's write that again. So 2 equals, I'm writing this equation, equals M2, don't know it, times V2, which is I know it's 6 minus 3. So 6 minus 3 is 3, so 2/3. So M2 is going to equal 0.67 kilograms. Okay, so it kind of involves substitution of one equation into another. And you should be able to do that. On a test, maybe we'll do it like, make it easier by having one of the objects at rest when it got hit. Okay, so that's the end of the complications with elastic collisions. Now, this can get tougher because you could have the balls bouncing off each other, hitting each other, not directly, but glancing off each other. So you could have something like this. Here's another ball. And when they hit, see, this ball is just at rest. When they hit, this ball will go off this way into ball 2 will go off down this way. We're not going to do those. Those get sticky because then we have to do X and Y components of the momentum. And we don't have a 90-degree angle between the horizontal, between these two momenta. So it gets complicated. You could do it, but we're not.